Welcome to Maths with EJD. So this is the third video in talking about the applications of integration, and it is about probability. I know if you've taken some probability courses, especially at the university level, you would have come across the usage of of integrals, right, to evaluate probability, especially if you have been taught about discrete variables and continuous variables. So for discrete variables, you use summation, and then for continuous variables, you use integral because integral can also be seen, apart from integral being seen as anti-differentiation, it can also be seen as a summation. So that's why it's used for probability. I know the key things in probability are counting and seeing the proportion of things. For instance, you have three boys and five girls in a group, what is the probability that if you pick a boy at random, if you pick a student at random, it will be a boy, you know? So you have to take the number of boys and take it over the total of others. So that summation, if you are dealing with continuous variables, will require you to use some integration. And that is why probability is one of the areas where you apply integration. So let's look at this. Given the probability density function PDF f of x, the probability that a random variable x will be in the range AB, the closed range AB, is expressed as probability that x lies between A and B, and that is equal to the integral of f of x from A to B dx. So integral of f of x dx within the range A to B. So another thing you need to understand is that for all probability density functions, it is always true that if you sum up everything from negative infinity to positive infinity, it is always one because no probability goes beyond one. So if you're looking for the probability that something will happen and you get minus, you get something negative or you get something greater than one, then you know something is wrong somewhere for sure. If it is actually probability you're looking for, right? So the next thing is, so you can see integration plays into this too. So summing up everything within the whole range. So this is what is analogous to you having maybe the summation of all, maybe for discrete function, all f of x is equal to one. Same thing. So if you sum all possible probabilities, you get one. Okay. And then the expected value or arithmetic mean of a large number of independent outcomes of x can be obtained as expected value of x equals integral from minus infinity to infinity of now x times f of x dx. So now we're talking about expected value or the arithmetic mean if you have a large number of outcomes. So you see integral playing out all the way here. So let's look at specific scenarios where we have this. For instance, look at this first one. Show that f of x equals 1 over 9x squared is a probability density function on the interval 0 to 3. How do you know that something is a probability density function? It has to fulfill the rule that the summation for all over all possibilities is equal to 1. Meaning, here we need to show that the integral of f of x dx from minus infinity to infinity is equal to 1. That's how so if it is not equal to 1, then it is not a probability density function because all probability density functions must follow that rule. So we proceed as follows. You have integral from minus infinity to infinity of f of x dx. First of all, you can break this down. You are given this interval 0 to 3, but this is the rule. The rule says minus infinity to infinity. So it means you have to break it down into stages. So you have the same function, 1 over 9x squared all the way, but then the intervals are different. The first interval, minus infinity to 0. So this function does not exist from minus infinity to 0 because we are given 0 to 3. So it doesn't exist from minus infinity to 0. It exists from 0 to 3, but it doesn't exist from 3 to infinity again. So it means all these two will have to go each time you have something like this. So then you end up focusing on the interval, the range which you're given. So minus infinity to 0, 0 to 3, and 3 to infinity. 0 to 3 because 0 to 3 here because we have 0 to 3. So, and since this thing is only defined for this interval, so it means for every other interval it's out. So you have 0 here, 0 here. So at the end of the day, you end up with this. You have 1 over 9 integral. So take the 1 over 9 out. So 1 over 9 integral of x squared dx from 0 to 3. And if you integrate x squared, you get x cubed over 3, which is the same thing as 1 over 3 x cubed. And that has to be evaluated from 0 to 3. So you can take out this 1 over 3 again to join 1 over 9. So you have 1 over 9 times 1 over 3, and that's 1 over 27. And you have x cubed to be evaluated from 0 to 3. So now evaluate. You have 3 in here. You have 3 cube minus 0 cube. And that is 1 over 27. 3 cube is 27. 0 cube is 0. 27 minus 0 is 27. 27 cancels 27. And you have 1. So since you have that, therefore, you can say that f of x equals 1 over 9x squared is a PDF on that closed interval 0 less than or equal to x less than or equal to 3. So that's one application you found right there. So let's take another example. So if the probability density function for the profit, if the probability density function for the profit from a cryptocurrency investment is f of x equals 1 over 9x squared, with possible profits ranging from 0 to 3 millions of naira. This is like a range now, right? What is the probability that an investor makes a profit between 1.5 million and 2.5 million naira? Okay, so possible profits ranges from 0 to 3, but then we are looking for the specific profit between 1.5 and 2.5 using the same probability density. All right. So now we are looking for a probability. So here again, it may be necessary to sketch. So you can see 1 over 9x squared is actually a parabola, right? Passing through the origin like that. And of course, we know the overall range is 0 to 3, but then we are focused particularly on 1.5 and 2.5. And so this is the area we need between 1.5 and 2.5. So we have already, okay, let me not go ahead of myself. So, I mean, this is the graph of the PDF, f of x equals 1 over 9x squared. And the region 1.5 less than or equal to x less than or equal to 2.5. That's because you're looking for profit between 1.5 million and 2.5 million. That's the region that has been shaded in green now, as you can see. So then we go ahead to apply our integral. And this is it. So here we have the probability is calculated as follows. Probability 1.5 less than or equal to x less than or equal to 2.5 is equal to integral from 1.5 to 2.5 of 1 over 9 x squared dx. So you can take out the 1 over 9. So you have 1 over 9 here. So you have integral from 1.5 to 2.5 of x squared dx. Integrate x squared, you get 1 over 3 x cubed. That's x cubed over 3, right? Which is 1 over 3 x cubed. So take out the 1 over 3 like before. You have 1 over 27 into x cubed to be evaluated from 1.5 to 2.5. And that is 1 over 27 into 2.5 cube minus 1.5 cube. So if you expand if you do all that, 2.5 cube is 15.625, while 1.5 cube is 3.375. And then you subtract and you get 1 over 27 to 12.25. So if you, do all that together, like you change it to fraction, you get 49 over 108. You can punch your calculator straight and you get this result, right? That is 0.4537. So if you're an investor and you have those details, so it means the chance that you're going to make a profit between 1.5 and 2.5 is actually almost half. That's 0.4537. And some of these things are actually used in finance, right? So you can be more methodical even in your investments. Okay, so let's see again, same scenario, but then another angle. We need the expected value here. Of course, expected value is not probability. So it's some kind of average. It's what's that mean called now? Is it arithmetic mean also? So find the expected profit. We need the expected profit. So you see expected, it tells you you're looking for expected value. So the expected profit from a cryptocurrency investment is probability density function, f of x equals 1 over 9x squared, defined over this range, where x is in millions of naira. So what is the expected profit? So generally speaking, the expected profit is obtained as follows. You have expectation of x, which is the integral from minus infinity to infinity of x multiplied by f of x dx. Previously we've been using just only f of x. So now you have x times 1 over 9 x squared dx. Then you can take out the 1 over 9. So you have 1 over 9. X times x squared is x cubed dx. Okay? So now, and that's from 0 to 3, right? So you have 1 over 9 out here. So if you integrate x raised to power 3, you get x raised to power 4 over 4, which is 1 over 4, x raised to power 4. And that's to be evaluated from 0 to 3. So you take out the 1 over 4, so you can, concentrate on the x. That's 1 over 9 times 1 over 4. That's 1 over 36. X raised to power 4 to be evaluated from 0 to 3. And we are not done yet. So we go to the slide where it's completed. So that's here. Okay, so here you have the expected value now, as you can see, is you are going to do 1 over 36 into x raised to power 4 from 0 to 3, right? So you put 3 in x raised to power 4, you get 3 raised to power 4. Put 0 in x raised to power 4, you get 0 raised to power 4. 3 raised to power 4 is 81. 0 raised to power 4 is 0. 81 minus 0 is 81. So you have 81 over 36, which evaluated 9 here is, I mean, okay, 9 here is 9 times. 9 in 81 is 9 times, and 9 in 36 is 4 times. So 9 over 24 is 2.25. So the expected profit, from this kind of investment is 2.25 million naira. Therefore, the expected our average profit from the investment is 2.25 million naira. So, and that brings us to the end of application of integration to probability. And as usual, I'll show you some exercise you can try your hands on, and I'll still show all this later, when I do the last video on application. So you see that here, question 1. I mean, the first question with 3 sub-questions. This, if f of x is x cubed minus 3 over 2, defined on 0 to 2 is the probability density function for the number of goals scored by a player in a match. So prove that f of x is a PDF. What is probability that the player scores from 1 to 2 goals? That is the range closed interval 1 to 2. What is the expected number of goals for a player in a match? So you can actually use the idea here. So make sure to subscribe, hit the notification bell so you can get alerted when new videos are released. See you in the video talking about the application of integration to volumes.